Welcome back. In this video I'll be solving a little problem 838, push dominoes. Okay, we are given a dominoes line, we place this one to go. Okay. I think I got the gist of it, so we have left, right, blah 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 blah. Okay, so essentially we have three kind of cases. So if I choose first left, then like this one, then everything left of it will be kicked down. If I have unturned one, it stays, but if there is something that goes that's been pushed to the left, right of it, and it's a first thing, this one will also be thrown off. But if it's turned to the right, then from this point on we don't touch anymore, and we just turn to the right up until we have a situation that there is something turned on the left. And if there is something turned on the left, we need to check how many there is in between, because if it's odd number, then we have one in the middle that is still standing, and if it's even number, then all of them are so kicked, and it's always halfway, so yeah. And if there is nothing that's kicked to the right, we just keep it. So let's try to get this working. So I will have I'll call it cutoff, or let's call it safe. So safe is currently, or let's call it maybe from, well, it's cutoff is better. So cutoff, and right will be equal 0. Range length of. So what do I do? If what if I have two lefts? Well, if cutoff is increased, I don't actually care. Okay, yeah. But cutoff is increased also each time there is no way something will be pushed down, so let's try with this. So if dominoes of I is equal this, then we just continue. Dominoes of I is equal right, then for sure I have to put right is equal to 1 and cutoff is equal to I. So I know from this point on everything to the left is okay. Okay, that's it. If Dominoes of I is equal, hold on, this or this, so left. Then I need to check and the right needs to be also fed up, so that's after the loop. If Dominoes of I is equal to left and if right is equal 1, that's first case. So in this case, maybe let's do right is equal 0. So everything from for j in range, so from cutoff up until this index I, cutoff I need to put Dominoes of j is equal I'll cheat a bit, so left right equals 0 for j in range cutoff up until I, d of j is equal to L. Cutoff is now I plus 1 because nothing on can be changed. So when right stays 0, else right is equal 0. So that part. So we know that left of this left is some right, and now we have to so for j in range, so from I minus cut of the range I minus cutoff I minus cutoff total is equal, if I have one on so R is on 0, 1, 2, 3, 5, 6, 7. 3 minus 7 is 4. So minus cut off minus 1. So in this case it will be 3 and each one will get 1. If there were 4 elements, for chain range total, so if total is less than, if j is less than total, so if it's 4, so 3 is 1, j is, let's keep it like this. If it's less than this, Dominoes of I minus j is equal to left, else Dominoes I minus j is equal to right. And if total mod 2 is equal 1, then of I minus total divided by 2, so minus 1 minus 1 minus 1 is equal to this. Okay, I think I did that part, and again cut off is equal to I plus 1 again, so I have if it's left, if it's right. And in the end, so it's somewhere here, if right is equal 1, origin range in chain range cutoff. If right, there is also a case, so it's not directly, but for j in range I minus cutoff. Dominoes of I minus j minus 1 is equal to right. Still one, so something like this, and for j in range so from cutoff on cutoff until length of dominoes is equal, right, something like this. Return from this is the my close. Let this go. So this should be later. So if this, then I do this. Also put, either way I put right to the 1 and cut off. So this was my bad. Okay. And now I think I'm just off by 1. So if it's, yeah, I'm off by 1 here. think this. So now I still not good, so right. Maybe this. I think that was good. So if the difference is 3, where is that part? If it's left, right 0, right total minus. So this is the number of elements in between. Let's go from 1 to total. So that's 1, 2, 3. Minus 1, minus 2, minus 3. For if j is less than total divided by 2. Here it goes equal. It's left. Else if, well, I can do else. So 1 will pass, but 2 will be R. 3 will also be R. And if total mod 2 is equal to 1, or if it's equal to 2, then this. I'll have to be closer now, so it's again wrong, so they counted wrong. So this is 0, 1, 2, 3, 3 and 4, 5, 6. So 0, 1, 2, 3, 4, 5, 6, 7. 7 minus 3 is oh yeah. Well, I did the cutoff is here, so it's 7 minus 4, that's 3. So it is literally the number of elements. Total is I minus cutoff. So I have 3 elements from 1 up until total plus 1 for j. So if it's total plus 1 is 4, so it's 1, 1, 2, 3. So I address all of them. And now total mod 2 plus 1 actually minus 1. I think this should be good now. So for these I'm good, but why? So total is I minus cutoff. So it's the literal number of elements. So that's 3. And here I need to do this. Okay. Let's just submit. Okay. So I got R. Plus 1 was cut for J in range. So I had right. I had nothing. Then I need to update. Straight is 1 and cutoff is I plus 1. 2, 3. This one is weird. Should be good in my opinion. For Jane range, let's print right cut off right and cut off 1. Let's just do length of D. So 1, 4, 5. It was 1 for J in range 4 till 5. What? Oh yeah, silly mistake. Okay. Well, this was pretty bad, but hacky, but yeah, works. At least it works. Let's see complexity. So space is easy, that's all fun. And time complexity, well, in the worst case, I'll have to go 2 times if I'm correct. So I think this should be all fun. Let's check if we can. Yep. And often. By often because well, each time we have to do the, let's say, double check for the, or double work for some index. It's never done again anymore. So either we'll do 2 times or 1 time. So That's at most 2 times n, and that's of n in big annotation. And space is pretty clear. So yeah, not very nice, but works. So I think it's fair solution. If you have any questions regarding this, leave them in comments. And I appreciate you following this one, and see you in the next one.